Hi, I'm Leonard Padeling. I work on systemd. I'm going to talk about portable services that are ready to use. Portable services is a new concept in systemd. And yeah, I'd like to introduce you to this. I did this talk before, by the way. You might have seen it if you attended DEF CONF, or if you have seen it at All Systems Go. There's not going to be much new in that if you saw it there. And probably would be cool if there's still people outside. Are there? Yeah, there are still people outside. So if you have seen it, yeah, you wouldn't miss anything. But apparently nobody has seen it yet. If you have any questions, totally interrupt me right away. I much prefer my talks to be like conversations and instead of just a Q&A at the end. So do not hesitate, interrupt me. I love that. Yeah, let's jump right in. Portable services. What are portable services? Portable services, you can see two ways. Like one way to see it is they're system services with some container features. But you can also see it the other way around. They're kind of like containers, but with some system service features, right? What does that mean? Like first of all, we have to understand what containers are. I don't really know what containers are. Different people have different ideas about containers, what they precisely consist of. I think the definition that I tend to agree on is that they combine three concepts. One is resource bundles, right? That's what you do with containers. You pack them all up in a couple of tarballs, like shared libraries and all the dependencies. There's isolation, meaning that they generally run in some form of sandbox. Like might be a better one, might be a worse one, but there's at least some form of isolation generally. And delivery, right? Like you deliver them on the server you want to deploy them on, and then you can run them there. So these three concepts is what at least I find most interesting about containers. I'm pretty sure that other people who care about containers probably would list more there. Portable services try to take some of these features and add them to classic service management. Specifically, portable services is about making resource bundles available for regular system services. They are about integration, right? Like if you look at the previous slide, I had isolation there. I put integration here, right? Like because that's what system services are really in comparison to containers. They're generally much more tightly integrated to the host system. And sandboxing, right? I do not put delivery on this slide because I don't really care about delivery. But yeah, the difference really here is I don't care about delivery, and instead of isolation, I put integration and sandboxing here. Sandboxing for me is slightly different from isolation because, like the way I see isolation, it's really about creating a new world that is separate from the host you live in, while sandboxing I kind of more see is like you're living still in the same world, but you can't do everything you want to do. Another key aspect of portable services is that it's supposed to be highly modular, which, like, to show the opposition to classic container management is that, like in container management, you generally tend to have to buy into the whole idea, right? And then some people don't do that and, for example, end up with containers which they introduce the concept of super privileged containers, which are basically containers where you just throw one half of the concept away by turning off all the isolation features. But yeah, portable servers are not supposed to be like that. Portable servers are supposed to be modular. You pick exactly what you want. Do you want the resource bundling? And if you want to have sandboxing, you pick exactly how much isolation or integration you want. So it's really supposed to be modular and very, very fine-grained and doesn't require you to buy into the whole idea, but into parts only. Another way to look at it, consider range from integrated to isolated. If I was a good graphics artist, I would actually have drawn a graph here, but I'm lazy, very lazy, so I just put a couple of words here with an arrow in the middle. Think about a range from integrated to isolated, right? On one side, you have the classic system services, right? Like these are System 5 services or systemd services. They tend to be very well integrated into the host, right? They live in the same world, they see the same network interfaces, the name file systems, they can establish file systems, mount them, and do things like that. They see the same users, they see everything because they are part of the host and they have full integration. On the other extreme, there's VMs a la KVM, right? They tend to live in their entirely own world, right? Like they could be living on a different host after all. And the way how they communicate with the rest of the stuff that runs on the local system is actually across the network, right? Like, so you get a maximum isolation. Docker-style microservices are probably somewhere in the middle, right? They it's not entirely clear if they are more like system servers or more like VMs. I put them on my little range here in the middle. Full OS containers are Alexi generally try to be something very similar to KVM, right? Like they expose a system that runs an init system inside and that you can SSH into. SSHing into is probably something you wouldn't do into Docker containers. Yeah. And now the concept that I'm going to introduce is portable system services, which I put close to classic system services, but somewhere on the range that goes towards Docker, right? So just to position this on a one-dimensional axis of integration versus isolation. Yeah, think about what's actually shared and not shared with these forms of virtualization, right? Like classic system services obviously have shared networking, right? Like they don't configure that. Like if I install Nginx as a System 5 service or as a system service on my system, you don't configure networking explicitly for it. You just use the host networking. While on the other extreme, of course, it's completely separate, right? Like they have to run their own network management solution inside of the VM for things to work. If you go along the axis, of course, yeah, Docker-style microservices generally do not configure own networking, but they also don't share it with the host, so you have a relatively, like, yeah, but it really depends on how you configure things. LXC generally, also, it's like a little bit vague, but yeah. Think about file systems. Generally, Docker-style microservices do not share the file system, right? They have a different root, right? So they are relatively separate in this regard. Yeah, classic system servers, of course, are fully integrated. They see the same files and directories as everybody else. VMs live in a completely different world, right? Like they have their own block devices even and mount these block devices and see something that the host cannot even see, right? Think about PID namespaces, right? PID1 in classic system services is the same as the host, right? Like because it doesn't live in a new PID concept, right? Like in PID 55 that the classic system service sees is actually the same PID 55 that's actually running on the host, right? In Docker-style microservices and everything to the right, that's not the case, right? Like they generally live in their own little world where they have PID namespaces, and yeah, PID 1 inside of it or PID 55 or 77 is going to be something very different from what the container sees and from the host, right? And then VMs, of course, PIDs are separate too, right? So you see, yeah, the PID namespace where the boundaries is somewhere there. The init system, it's kind of similar, right? Like where is the cut there? If you have classic system service, they of course share the init system with the host. I mean, that's what started there. If you do Docker-style microservices, that's kind of weird because they generally don't have an init system. Like there's no init system visible from the containers, but they also don't have their own. If you do LXC, then yes, you have an init system inside of the container generally. I mean, yeah, people can disagree with me on this that, yeah, you can configure it differently. But yeah, I'm trying to position this in the general case how people tend to actually use this, right? Device access is also, yeah, if you do classic system services, you generally have raw device access, right? Like you can access the block devices like the sound card or whatever physical devices your computer has directly because you're living on the system, right? This is very different, of course, in VMs. VMs are generally isolated completely. Yes, I know that you can do pass-through and things like that, but that's magic manual working to make this happen. It's not how this works out of the box, right? And logging, on the other hand, tends to be much more integrated. Like even Docker-style microservices tend to log like provide the logging, and it's not done by the payload itself. So yeah, so the point of this lower thing is that it's actually, even though the axis suggests it's a linear axis of integration, it's actually more multidimensional, right? Like depending on what you look at, the cut where you get the integration and the isolation is more to the left and more to the right. I hope this makes any sense so far. Okay. Then portable services, one of the goals with portable service we had is leave no artifacts, right? Like in containers, that's kind of a given, but on system services, it's not, right? What do I mean by that, actually? If on a Linux system you install Nginx or MySQL or whatever package you like on your server, right? Download the depths or RPMs, install them, and then remove them again, right? This leaves artifacts around, major artifacts. For example, on Unix, users are generally, like, you cannot sensibly delete system users, or any kind of users actually, because if the user is created in some directory, some file, and you remove the user, these files will still be owned by the user ID of that user, so the file ownership is sticky, and if the user doesn't exist anymore that the file ownership refers to, then you have a problem, and then if the UID gets recycled later on, you have a security issue, right? So this is a problem, I think, with Unix since forever. Most distributions generally do never delete users, right? So that basically means you install Nginx once, you remove it again, yeah, your UID is gone for good. With portable services, our attempt was to fix that problem and provide a way how user IDs can be used, but they also become inherently transient. We'll talk about that in more detail later on. What this specifically means, but it's not just about system users actually. There should be no artifacts left around, like if you ran a service and you remove it again, like for example temporary files should be gone as well, right? Yeah, it's about binding life cycles. That when a system service starts up, it can allocate a couple of resources. When it shuts down, they are released, and unlike classic system services, we don't leave stuff around. Another goal of portable services is to have everything in one place. This is kind of the bundling thing, right? Like, yeah, it's not a new concept, of course, because chroots existed in Unix since forever. In fact, the whole of portable services you can summarize as, yeah, making chroots useful. Yeah, it's one of the key goals. You know, I'm a system service guy, of course, because, yeah, I wrote most of systemd. So for me, yeah, doing chroots is awesome, but I want to make them viable to service managers in a very, like, just regular system service in a very powerful way, and that's what portable services are. Another goal is I want this new concept that adds these couple of portable of container features to service management a lot like a native service, right? Because I want it to actually be a native service. Native, by this I mean like a regular systemd service, like that has a .service file or so on. So the ultimate goal after this is that if the portable services are used, then you end up having an init system that supports 3 formats for services. The native ones, classic ones, systemd service files, the old system5 init scripts, right, and these new portable services. And as you, like, if you're using systemd, you already notice that the behavior of system5 init scripts and regular systemd services, the behavior, like, you do system control start and stop on them and can reset resources and see the logs of them. It doesn't really matter, like, this distinction is removed. The key with the portable service concept is to do the same here too. Okay, so much about the goal, so much about the positioning of this new concept of portable services. Let's talk about the why, right? Like, this is a question we always have to ask. Yeah, I already mentioned that I'm a service management guy, so we don't live in a vacuum, right? Like, things happen around us. Containers happen, of course, right? They have a lot of mind share, and they are in a way a form of service management, but a lot removed from the core system. But there are definitely a couple of good ideas that I think make a ton of sense to take and apply to system service management as well, right? It's not about coming up with anything new. It's just about looking what's good, what's out there, and then figuring out, is this something that we want for service management, like for regular service management as well? And I think this, yeah, the bundling and the sandboxing is. So let's apply it there as well. Also, what's really interesting to notice is at this point in time, pretty much all packages of service that are viable tend to have native systemd service files, right? So in a way, most of the stuff that already exists on the internet tends to have these service files, and that's actually kind of cool because it allows us to if we add a little bit of on top, we can do something that goes in the direction of containers without actually defining any new kind of metadata. Because we already have the service files, and pretty much everything has these service files at this point already. Yeah, another concept is like, you know, containers is a separate world where you use different tools. Admins generally are used to system service already. So maybe we can just make them more powerful in some regards because, yeah, some of the features that you want to have in containers, you can just make available for regular system services as well. One primary use case for portable services, I mean, just to make this clear, this is not an attempt to reinvent containers or something like this. explicitly want to position it as something that is more low level than this. And I explicitly want to position it for use cases where containers might not be the most appropriate way to do things. Like if you want to use containers for something and containers are the right choice for what you do, continue doing this. This is supposed to be a little bit more low level. So one primary use case is what people have dubbed super privileged containers so far. It's, for example, storage people like to do this, right? Like they want to ship a lot of complex stack in one image onto your server machine, right? That's why they want to use containers. But on the other hand, they need a really strong integration into the host system because they need to do device management, like block device management. They need to figure out what's being plugged in, what iSCSI does, and whatever else, right? So they are in this weird position that they would like to ship a lot of complex stack software with its own dependencies because it's all far from trivial onto existing machines, but they also want the full integration into the host because they do device management, and if you do device management, that's where you really, really need it. So yeah, inside of Red Hat, there was people working on super privileged containers. When I saw that, I said, this is horrible, like, because they ended up using Docker initially, and then they turned off all the sandboxing features and created all these bridges that inside of that you could escape from inside of the Docker to the host, so that they could do the manipulations of the device that and everything is like. But yeah, portable service is supposed to cover that use case perfectly, right? Like so that you can have your bundling and all these kind of things, but you can pick exactly how much you want to see from the system, or how much you want to be isolated from the system without being completely and terribly ugly. Yeah. Also, one of the key ideas is integration is a good thing often, not the bad thing, right? Like with containers and all these things, they're very strong about isolation. I think in many use cases, you want the integration. Not in all, but in many you do, right? So yeah. It really depends on your use case, integration, and the ability that you can introspect the rest of the system, in particular for tracing tools and debugging functionality and metrics and these kind of things. It's a really, really good thing if you do not have to first play games with the sandboxing to escape it. Okay, I kind of mentioned this already. One of the goals is that, yeah, the System 5 services, the native service and the portable service are supposed to be next to each other and equally well supported with the same interfaces and same behavior, same resource management, same everything. The building blocks this all is built off are actually permit more, right? Like the portable services code base is actually relatively separate. Like when we added that to systemd, like the portable control command that makes all of this available, it didn't actually require any changes on the systemd core itself. It just added a new utility that allows you to interface with the existing sandboxing options and bundling options in a nicer, more integrated way, right? So this is kind of, because it is implemented that way, it basically even would allow you to come up with your completely own service delivery framework, use all these basic concepts, and build something completely different, right? Like, for example, people have been working on making OCI stuff work and translate them dynamically into native systemd service and things like that. Yeah. One key idea about... any questions so far, by the way? Nobody has interrupted me yet about all the stuff that... Okay, let's talk a little bit about disk images, right? Like when we think resource bundling, we have to think about disk images in some form. Docker, as you know, uses tarballs and then weird layers and AUFS and these kind of things. Yeah, one of the goals with portable services was no new metadata, right? Like I didn't want to sit down and come up with a new OCI spec. I have no interest in whatsoever in that. I didn't want to define a new image format or anything. I have no interest whatsoever in that, and it's like a political massive job. So with systemd portable services, the key really is we use the metadata we already have. Specifically in disk images, this means we don't care how the bundled images come onto the system, as long as the moment you actually want to start them, they are accessible as a Linux accessible file system in some way. We're happy. What does that mean? You can ship things as tarball if you like and unpack them, and then systemd can use it as a portable services, but you don't have to. You can also use it as a disk image, right, like a UEFI block device image that you can mount. In systemd, with the portable services concept, we support both equally, right? The key, what we just require from people is that they provide images on the block layer or on the file system unpacked layer, but in both cases it needs to be something that the Linux kernel natively supports.
Do you support native file system images like Squashfs?
Yes, that's kind of what the point that I was making, right? It's like I don't really care what you use, and we explicitly support both block device level stuff and unpacked tarball kind of stuff, right?
So, but not just a file system. You need a block device with partition tables in.
So the question, I was supposed to repeat the question, right? Not just, so the question was regarding whether whatever is mounted as a disk image has to be a proper block device, or if it can be just a regular file. The idea is it's just a regular file, right? It can be a block device, but the idea is it's a regular file, and systemd will internally do the loopback mounting and stuff like that. So you will never actually see that there are loopback devices and block devices involved in the end, but the idea is generally either take a tarball, uncompress it, and you operate on the file system level, or provide us with maybe a Squashfs file, and systemd will set it up as a loopback and mount it, and then it's kind of the same thing from that point on.
Yeah, you can point at a folder, right? Just say this folder is the file
Yep.
system.
So the question was regarding, if we can point it to a folder. Yeah, that's the tarball option, right? Like that I mentioned, right? Like the fact that tarball is used, I don't give a damn about that, right? Like as long as it's there in a format that the Linux kernel natively supports, which could be a directory or could be something that I can mount, I'm happy.
Are you aware of anybody, I guess maybe at Red Hat, using OS3 with this?
So the question was regarding whether I know of anybody using OS3 with this. I heard of people who were interested in this, but I didn't follow up in details. But of course, you can totally use OS3, like, because as mentioned, if it's a directory, it's good enough for us. And OS3 stuff, after you check it out, is just a directory, so all is good. So.
Let me follow on from that. Because it does that, I was going to ask this later, but I'll ask it now. I was thinking about how this relates to the stuff that I was doing about system, like using systemd to stuff in own things. And then I was wondering, is this partially you trying to park your tanks on Flatpak and snaps, like raw? You take the delivery bit out, which you're not interested in. It's sort of simply like the same territory, right?
So yeah, the question was probably, I guess I can summarize it, the relationship to OS3 and snaps, right? Yeah, to Flatpaks and Snap. So, I mean, the key really here is this stuff is system level stuff, right? So, Flatpak's not system level stuff. Snap is, though, right? This is actually in the design very close to Snap what it does. But, I mean, I don't really care about the disk images as mentioned, right? You can actually use even a Snap disk image if you want. The focus that I have really is after it's there, how to make the stuff that's in that image available as a regular system service, right? And this is what they generally don't care about or want to provide. So Flatpaks, different story, desktop stuff. This stuff requires privileges. People have asked about making this available unprivileged, but it's kind of difficult because at least if you do disk images, it's all about mounting and loopback devices, and none of that is available unprivileged. I hope that answered the question a little bit. Yeah, key here really is let's avoid something new, right? I don't want to be in the business of defining image file formats. So yeah, let's just take simple directory trees or better subvolume, or maybe a GPT containing Squashfs, but actually we don't really care if it's Squashfs, and we don't really care about if it's GPT either. I just think it's a nice thing to do. The services run directly from these images, right? There has been this root image and root directory service setting since ages in systemd. We just make use of this here to say, yeah, now I run the service from this image, and then the moment the service starts, this image is mounted, if it's not mounted yet, or bind mounted, and this is the moment the service shuts down, that the image is not used anymore. In a way, this is about like fixing chroot. I mean, chroot has been around since ages, and some people have deployed things like that since the 90s. But chroot has a couple of serious problems. Like, for example, one of the bigger ones we'll talk about later on is about like etc passwd, because you kind of have to synchronize the etc passwd on the host with the container. We'll talk about that, what we're doing in this area. What's, by the way, interesting, because we actually do, so like root image, this stands as basically where you specify a squash file system, like any kind of file system that the kernel mounts. Root directory is where you specify a directory. But the root image thing is actually kind of nice because when we mount this stuff, we can actually take benefit of all the weird storage stuff that the Linux kernel has. Two things are particularly interesting, I think. Like one is you can LUX encrypt, for example, an image, and then just make systemd start the service from it. So you can have a model of basically encrypted services. And Verity I find even more interesting. Verity, for those who don't know, is a kernel concept about that every access to the disk, or in this case to the image, is verified as the access happens cryptographically against some predefined hash value that can be signed. So with that, you can actually make trusted services in a way where you basically say, yeah, I have this computer here, and it will only run software that is signed by me, and then you deploy an image on it, and then systemd will start it, but systemd will only start it if the top-level hash of that image is matches against some signature checking stuff that makes sure that it's only my stuff that runs. Don't want to talk too much about that because that's probably a talk of its own. Just wanted to mention is simply by the fact that we rely on whatever the Linux kernel provides us with, we can make these things happen. And we did make this happen. It's all hooked up. So, yeah.
Does it mean that we can use our distribution, for example, and start single service from it?
So the question was if this means that we can use another distribution to start services on some host system. And yes, this is what it means, right? Like the idea is that much like for containers, the distribution that is used inside of this image doesn't have to match what's on the host. And things should still work just fine because the Linux kernel people might not be perfect in maintaining compatibility with everything, but they're pretty good, right? Okay, yeah. The only thing that an image needs to have to qualify as a portable service is that it has to carry systemd unit files, that it has to carry a file user-lib-os release, and that's it. It has to carry systemd unit files because we need to know what to actually start in it, right? Like, so it has to have that. As mentioned, it's kind of cool that all software that currently exists generally has these already. And the user-lib-os release file is something that has been existing since 5 years already. We came up with this originally in the systemd context, but it's actually adopted universally even beyond, even the systemd haters now ship this file. It's a very simple file that is supposed to describe the distribution you use, but it's actually extensible. So our ideas was, we use that as a metadata information that if you want to declare what the image that you have there is about, you just add a field there. And, so again, the key here is no new metadata, no new formats. We use Linux file systems, we use systemd unit files, you use the OS release file, nothing of that is new. All of this exists for at least 5 years, and in many cases for 10, 20 years. Any questions about this so far?
So in this case, if you don't want to use portable control to start the service, the portable service, you have to declare like a host system service file to load the portable service, which then in turn carries the system service file.
So that was a very complicated question, and I would like to delay that to the end. If I hope we have enough time, we'll kind of introduce a little bit to the command line, if we have enough time to, because that will, I think, explain your question. Somebody else had a question? Again? Okay, then let's talk about that a little bit later. One quick slide. I mean, there's lots of stuff on this, but I don't want to go too much into detail. The point I want to make here is like systemd for a long time had all these sandboxing options for system services, right? This is independent, like as everything else that I said, from the actual portable service concept. These things existed since some longer, some shorter, but they are generally options how you can lock down your system services. Just as an example, private devices, for example, is a boolean that you can set on a system service. If you turn it on, it basically means that the service gets its own instance of /dev that doesn't contain any real devices, but dev uren, dev null, dev zero, and these kind of pseudo devices that are Unix API or Linux API, but don't actually reflect to real physical devices you could touch. And there are a couple of other options of this where they are generally designed to be super easy, like booleans or something very close to being just a boolean, how you can lock down your services. In the portable services concept, we just make use of the fact that this already exists. There's one major difference, though. You can turn these on your classic system service already, but they generally are opt-in so far, right? Which is something I mean, we would like to turn that around, of course, but at this point we can't really for compatibility reasons, like because system services have been around, like, I mean, they inherit everything from System 5 even, and since System 5 and in the beginning systemd services did not have sandboxing, if we would turn that on by default now we would break everything, right? So for the classic stuff, it's opt-in. For the portable services, we have the luxury though, because it's a new concept we just introduced, it's the reverse, it's opt-out, right? Like, so by default you get a policy, but you can actually opt out from everything. And if you do, then you get a full integration into the host system, can do whatever you want. Yeah, these are a couple of that we already have. I did talks in the past talking about all of them in detail because they actually do feel like a talk of their own. There are gonna be more. There's also nowadays, which is really interesting to know, is like the per service firewalling these days, where you can set inside of the unit file, you can do access control on IP level and things like that. This is and IP accounting actually this is so awesome, but yeah, it kind of fits into this whole sandboxing concept. Yeah, I already mentioned this. Sandboxing is opt-out for portable services rather than opt-in. How much time do I have? This is 20 minutes. Okay, let's talk a little bit about these hard problems. This is, I kind of already mentioned this. If you do chroots classic on Unix, you have this problem that, yeah, because the chroot environment generally doesn't see the user database of the host, both like the host and the chroot environment might have a different idea what UID 500 means, right, or UID 1000 means. So most of the how-tos that you find on the internet that tell you how to manually set up a chroot are by, yeah, copy over etc passwd. Yeah, because portable servers are ultimately just a way to make chroots more useful to work. We try to figure out what we can do in this area. For this, we added a concept called dynamic users. Dynamic users is something that is particularly useful in the context of portable services, but you can use it already on your system independently of it. And yeah, it's the one building block, but the building block can be used in any context you like. It just happens to be one of the building blocks portable services are built on. What are dynamic users? Dynamic users is a concept where you basically can say for a service that when the service starts, a system user is registered, and when the service shuts down, it's released again. Right? I've already mentioned this problem. Now you have this problem with the file stickiness, right? So that yeah, when the service then goes down and the service the user ID is released, what happens to the files that the service created while it was running? Our solution to this is a couple of things. First of all, when the service writes something to /temp or /vartemp, yeah, it won't be able to do this. What it instead will do, it will get its own fake little /temp and fake little vartemp that actually is backed by the real one, but whatever the service writes into that is automatically removed when the service shuts down, right? This is what I call lifecycle binding, right? Like the life cycle of the system is bound to the life cycle of the temporary files. So when the service goes down, the temporary files go with it, right? So that's one facet of it, but it's not particularly useful yet. So the other thing is, yeah, to deal with the sticky file ownership problem, our solution is we simply disallow the service to write anywhere, right? So it's a nice way to avoid the problem with sticky files by simply prohibiting files altogether, right? So this, of course, limits the usefulness because you then have a service that can write stuff to temp and vartemp but can't do anything else. I mean, it's good enough for probably some use cases, probably most use cases want to be able to actually write stuff to disk and like whatever they generate. So our way out of this is in systemd that's actually also independently useful of dynamic users and independent of portable services. There's a concept where you can specify a state directory inside of the service file. If you do that, that basically means that if a directory in var lib gets choned, like the ownership gets changed to the service's system user the instant the service is started, right? Basically the idea here hence is that systemd manages for you of specific directories the ownership, and these the service then gets access to for writing, right? This is a little bit ugly, right? Because it basically means that you start up your service for the first time, systemd creates a new directory in var lib for that specific service, changes the ownership of that directory to the system user. It also located for you. Then you run, you write some stuff to it, you shut down again. Now the user gets released, the data shall stick around, and it does. And then you start again, but now you might have gotten a different user ID. So what system has to do, it has to recursively churn everything. That is horrible, but it's actually not as bad as it sounds, because Linux is very much optimized on that. And even if you have a directory tree that's a couple of gigabytes, at least on my machines, it never took more than a couple of seconds to churn recursively through it. If it's something smaller than a couple of gigabytes, it's practically not noticeable. Also, system tries really, really hard to assign the same services, the same dynamic user IDs if they can, by hashing them out of the name of the service and things like that. However, given that the name, like the UID space, is a little bit too short, collisions will happen. In that case, it has to jump.
So in the meantime, the system stopped after running the first time. Do you change it to root only, or?
That's a very good question. So the problem is, of course, if the server started up, has its own directory, then our service goes down. Now these files are there, still owned by this user ID that now ceased to exist, right? This is, of course, the problem we always wanted to avoid. So what do? We take a lesson out of how containers are managed. Because in containers, they stored somewhere in varlib containers or varlib docker or something like that. And the way, because they have the very same problem, they also have a completely, they have a concept of users that only exists while the container is running. The way they avoid it is they have a top-level directory where all the containers are stored. And this top-level directory is not readable by anybody but root, basically, right? So they avoid this by adding a barrier in the middle, so that it doesn't matter if the files that are stored below are owned by a user ID that is otherwise recycled potentially now, simply by just cutting it off in the middle and saying, yeah, that entire subtree is not available to you. That's exactly what we do here. Now, this is actually harder than it sounds, because we want to make available varlib foo for a service foo. So what do? Do we change the ownership of varlib to 700? We can't really do that, right? This is actually tricky in the background. What actually happens there, there's a directory varlib private. And varlib private, that thing is actually 700. I hope you guys still follow this. This sounds like, without slides, really nasty to follow. So that one is actually 0700, and then there's a symlink automatically created from varlib foo into varlib private foo, to make it invisible to the outside. And from the inside, right, because the inside shall have access to this directory even though it's unprivileged, through bind mounts we make the varlib private hidden and instead mount it to the top. And I hope you kind of followed at all what I was babbling here. It took us a while to figure out that this is actually workable and is nice, and I'd really like to get rid of much of this code, and maybe one day we can, if we have shift-fs in the kernel, like the file system where you can actually change the user IDs. So far we can't. I don't know. I tried to come up with anything better and talked to a lot of people. We couldn't. The general runtime behavior of this, even though we do the recursive churning, is kind of nice, right? It's not as it's not a costly operation, because inode updates, because we never actually write to the files, we just change the inode ownership, are surprisingly fast on Linux on the file systems these days. There was somebody had a.
What if you need two services to access the same directory?
That's a very good question. So the question was, what happens if you have two services that want access to the same directory? The thing is, if they have two dynamic users attached to it, that's not going to work, right? Unix doesn't allow that. It would allow that if we have shift-fs, which we don't, right? I hope that we eventually can fix it and make this happen. As long as that is not available, though, what you can do is you can, systemd actually, when it creates these dynamic users, honors the username you specify inside of the unit file. Now, if you have two unit files, both of them have dynamic user turned on, and both of them specify the same username, systemd will actually create one and the same user for this, right? And if you do this, then you can actually share this directory, right? But it's really on you. Systemd won't help you right now with this, because I kind of still hope that shift-fs is a real thing eventually. I actually was at the container mini-conf just before here, where one of the guys actually talked about this, and he said that's gonna happen, but yeah, we'll see when that's gonna happen. But yeah, you can do it, but you have to be careful to use the same usernames for the services that want to access. Sorry?
Could you have not done something with groups instead?
So the question is about what about couldn't you use something with groups instead? But I mean, the general problem is that the user IDs. Yeah, well, I mean, the problem is that it's up to the programs then to make this happen, because they can't, for example, create files that have non-writable things like that. right? So in my assumption, like we thought about this, but using SEALs in particular to make something like this happen. But the problem I always saw with that is like these solutions tend to end up being something that applications need to explicitly support, because many applications manage their access control manually, while with this solution we went for, it's transparent to the applications. They don't know that there is, like, well, if they look from the outside, they will see the weird thymlink, but from the inside, there's no difference from a regular, yeah. So
the system file system, whereabouts does that mount? Where does that look like in the bind namespace inside the portal service?
So the question was, how does the file system look like inside of the services namespace, basically? Like, if you provide a image, right, like, for example, a squashfs image or directory, and then you have a unit file inside of it, and then you told portable control with the command that I'm going to show you later to attach this thing to the host, which basically means copy the unit file out of it, put it on the host, and update it slightly so that there's a root directory or root image setting that points it back to the image file. If you then start the stuff, what it sees from the inside is exactly what is inside of that image, except for the stuff where you punch the holes into. And the holes that you punch are generally something like state directory, the thing that I already mentioned. If you specify state directory in the unit file, it basically means that directory that you picked there in var lib is shared between a host and the user, and if dynamic use is turned on, which is an optional feature, then it does the magic UID stuff. And then there are a couple of other settings like this. There's, besides state directory, there is cache directory, which does the same in var cache. There is configuration directory, which you might guess does the same thing in etc. There's runtime directory, which does the same thing, and you might guess /run. There's one more. Logs directory, true. So where you get the same thing in var log. But the model really is towards pushing people to be more declarative in the services by denoting exactly which of the directories are actually relevant to a service, and then this actually doubles the way how you can punch holes into this sandbox in a safe way, because we do the dynamic user rechoning if necessary. The question is if we support arbitrary bind mount from the host. We do, but if you do that, then of course you can't use the dynamic user ID thing so easily, because we would have to chone magic, but if it's arbitrary stuff, we can't insert the valid private thing in between so everything explodes. But by all means, go and do that. Like, for example, the storage people, they would run their stuff as root anyway, not as a dynamic user, right? And for them, yes, use as many explicit bind bounds as you want, and make available whatever you want to have available. But I mean, yeah, so the question is regarding if distributions could ship tiny portable images and use stuff from the host. Yes, they can, right? I'm not going to prohibit that from you. This is a completely generic tool. You can misuse it any way you like. I'm not going to rule into that. Would I do that? Right? I'm not sure. Like, I mean, part of the idea about portable servers, of course, is that you, much like for containers, that you distance yourself from the ABI of the host, right? So to make the stuff more portable. Sorry?
You probably just use the existing sandboxing stuff directly, not the portable stuff.
Yeah. So 10 minutes. Okay, I got a couple of more slides. It's completely fine that I didn't cover this because I got so many good questions and even more here.
Is it possible to start multiple instances of a service, of portable service like this with normal system services?
So the question was regarding whether it's possible to start multiple instances of a portable service like it is possible with regular services. The answer to that is a clear and resounding yes, because these things aren't native services, right? So if you put a template file, like a template unit inside of a portable services, then you can instantiate it as many times as you want, just like you could do it with a template unit that is installed on the host. I want to, yeah, so let's...
One question. Do they then share the same user ID if you do this? The multiple instances?
The question was regarding whether if you do the multiple instance stuff, whether they can share the same user ID. Yes, absolutely, but they don't even have to be multiple instances of the same service in that case, right? As mentioned earlier, if you have two unrelated, otherwise unrelated services that are not instances of the same one, you can do the same thing. What's key is that you turn on dynamic users in both cases and that you set user equals the same string, which is the name.
If I want to have different user IDs, it's also possible.
It's also possible, right? So to repeat the question, if you want to have different user IDs for every instance, yes, you can do this too. Which is actually really, really awesome for the dynamic user stuff because you can actually implement trivially now a service that is socket activated, right? And for each incoming connection, a new instance is created, and each instance gets its own dynamic user that lives as long as this connection exists and then goes away again. To me, this is actually like just this concept of making user ID something cheap that you can have and then you can return them and they don't become this extremely expensive thing that stick around forever, and hence your package can only allocate like 1 or 2 or maybe 3 but never like 100 of these. This is actually one of the, like, I see it as a breathing new life into the Unix concept of user IDs, because suddenly you can use them for much more than you traditionally could. And that is so awesome actually, because user IDs are like the core security feature of Unix after all, right? Like all the other stuff that we have these days with as a Linux and AppArmor and whatever else is it with Seccomp came later and is specifically supported in only one concept. But the user IDs as a security concept have existed always and are built into every piece of our software after all. So adding the dynamic system user concept to that is kind of like, yeah, it turns something really established into a much more powerful concept. Okay, though, I'm going to talk about this slide here as my last slide then, just to give you a little bit of feeling. I don't have demo because demos tend to go wrong, but I want to at least show you how the concept generally works. The command you use for interfacing with portable service is called portable control. You invoke it, portable control, with the verb attach, for example. Foobar.raw in this case is a disk image, like could be, for example, a SquashFS image in there. When you do this, right, when you invoke this, then this portable service image is attached to the host. What does it mean? It means that, portable control will do a little bit of verification that it's the same image, and then it will just copy out a couple of unit files from this image. Which unit files will it copy? Actually, the ones that start with the same name as the image file itself. So if the image file is called foobar.raw, the unit files it copies out are foobar- whatever you like, as well as foobar. Whatever you like. The unit files that are copied out don't have to be service unit files, by the way. They can be socket unit files as well. They can be target unit files. They can be whatever else. Like not all of them, not all 8 of them that we have in systemd, but most of them. So you can, what this basically means is that you can package a couple of related units into one image, right? You just have to follow a little naming regime that you always call them some prefix dash some suffix, and the prefix is always the same. You can use socket activation, time activation, all of this at the same time, and just by portable control attach, all of them become available in the system. And from that point on, they are regular services. So at that point, you can do portable, system control start, system control stop, system control set property, system control whatever else you kill, whatever. You can do journal control -u with them, because after they're copied out like that, they are regular system services. There's nothing distinguishing them anymore, except for the fact, that they originally got copied out of some image file. And then, of course, there's
Also across reboots?
yes, portable control attach. If you call it like this, is actually across reboots. So the files are copied out into etc. There's actually portable control attach dash runtime as well, and you might guess it copies them into /run. So the attachment, the fact that the unit files exist on the host, goes away when you reboot. There's obviously the other verb that undoes all of this. It just removes the files that were copied out, and then at that point the services are not available on the host, right? Key again is leave no traces. The idea really is that besides logs, like because we never should delete logs, after you do the detach, nothing remains in the system.
Can you look at templated unit files as well? Can you use kind of templates?
So the question is, whether these can be template unit files. Yes, they can. The files that are copied out just have to have foobar as a prefix, followed by either a dot or dash. But what comes after that, it doesn't really matter. It can be a template. It can be an instance even. It's
You're running multiple kind of services with different
yeah,
things you can template.
yeah,
You can use template files to do that and then run
yeah.
multiple services like that.
Yeah. And by the way, by default, like the idea is that you enable them all at the same time as attaching, but you don't have to. You can attach them and then enable them, or you don't. It's completely up to you. Yeah.
I assume that the drop-in replacements work as well.
Sorry?
I assume that the drop-in replacements like can work as well, like in the search
Droplets.
Oh, you mean drop-ins? Okay. The question was regarding like the drop-in files we support for unit files, so that you can extend them on the host. Yes, these because after they're copied out, they are regular unit files. You can also extend the contained unit files on the host by dropping stuff onto the host. In Etsy and Run, like because they are native unit files at that point, they're not distinct anymore. You can do everything you can do. You can even do system control edit if you like, and then system control will drop in the unit file for you. If you do detach, however, these ones would not be removed. All right, because I mean we could probably add that, but it probably needs an extra switch because admins might be pissed if we remove the configurations the changes meant to have. This was my last question, so thank you very much, everybody. If you have further questions, I'm going to be outside. Thank you.